I hope all of you are doing good. Let's start today's chapter, Geometry. Point, line segments, lines and ray. We know that a point is an exact location and can be shown by a dot marked by a pointed pencil. In the given figure, A, B and C are points in the plane of paper. See, these are the points, okay? That's like this is a dot, this is a point, okay? Line segment, let A and B be 2 points in a plane. The straight path from A to B is called a line segment, AB. This is denoted by AB. The points A and B are called the end points of AB. The distance between A and B is called the length of AB. Thus, a line segment has a definite length and it can be measured. Okay. Next, line. A line is an endless straight path that extends in both directions. A line has no endpoints. Remember that. A line doesn't have any endpoint. Observe this figure. The line segment AB extended on both sides and marked by arrowheads on both the end represents a line denoted by AB. Okay. See, this is a line and we AB and we can extend in this line in both the directions. Okay. So, arrowheads on either side indicate that the line is endless. Okay. What does arrowheads show? That the line is endless. Sometimes lines are represented by small letters like L, M, N. For example, line L. So, in this figure, L is a line. Consider a point A, draw lines through it. What do you observe? See, this is a point A and you have drawn lines through it. So, what do we observe? We observe that an infinite number of lines can be drawn through a given point A. However, as shown below, only one line can be drawn to given points A and B. Okay. See, A and B, okay, we can only draw one line. Okay. Next is a ray. A ray is a straight path having one endpoint and extending endlessly in one direction. The end point of a ray is called as its initial point. In the given figure, AB is a ray and A is its initial point. Okay. Here A is the initial point of the ray AB. We write AB, see AB. This is the symbol for ray. Measuring line segments. To measure line segments, we use a ruler or scale. A ruler is marked in centimeters on one side and inches on the other. Each centimeter is divided into 10 equal parts and each part is a millimeter. Nowadays, inches are not in use. So, a ruler is used to draw line segments and measuring length of line segments. Consider the following example. Draw a line segment of 5 centimeter. So, we proceed as follows. Place the ruler on the paper, mark a point A against the 0 mark. Then mark point B above the mark 5. Now, keep the pencil at the first point and move it along the edge, keeping the ruler pressed evenly till the pencil reaches the point B. Then we remove the ruler and pencil, we get the line segment AB on the paper. And the length of this line, that is AB, is what? 5 centimeter. Next, to measure the length of a line segment. To measure the length of a line segment PQ, place the edge of the ruler in such a way that the 0 mark of the ruler coincides with P. Next, read and mark the number which the point Q coincides with. It is 6. Hence, the length of the line PQ is 6 centimeter. In cases where 0 mark of a scale is erased or not clearly visible, we can still use the scale to measure the length of a line segment. In such cases, we start the measurement from number 1, 2 or 3. And we can use a divider and a ruler also to measure the length of a line segment. A divisor is an instrument which has 2 arms with pointed ends. See, this is the divider which you will find in your geometry box. Example, measure the length of the line segment AB. So, what will you do to measure the line segment A and B? We place the end point of the divider on the points A and B of AB. Now, without disturbing its arm, place the end point of one arm at 0 mark of a scale and then read the mark where the other end of this divider falls. This distance gives the distance AB, which you can clearly see like this is 4 centimeter. Okay. 18.1 exercise. Name the line segments in the following figures. See, there are 3 line segments, 1, 2 and 3. So, you will write here AB, then AC and BC. Okay, students. Next, angles, types of angles and construction of angles. Angle. 2 rays having a common end point form an angle. See, one ray, second ray. okay, and having a common endpoint. This is the common endpoint. So this endpoint form an angle. Consider the figure given alongside. Rays OA, OB start from the point O. The figure so formed is called an angle. An angle is often denoted by this symbol. This is the symbol of angle, okay. The two rays OA and OB are called the arms of the angle, and the common meeting point O is called the vertex. Generally, we name an angle by the three capital letters. The letters at the vertex always comes in between the other letters. In the example, the angle is named as AOB or angle BOA, right? Sometimes an angle is named by its vertex letter. In the example, angle AOB can be named as angle O, okay. Now, interior and exterior of an angle. Consider an angle PQR. See, this is PQR. Consider a point X on a ray. Okay, see, this is angle P, Q and R. Okay. Now consider a point X on a ray QP, X, and a point S on a ray QR, S. Okay. We say X and S lie on angle PQR. Now consider points V and T in the inside of angle PQR. Okay, this is the inside of PQR, right? So you can write here point V and point T, okay. And U and W lie outside the angle PQR, outside this angle. So you can write here W and U, anywhere outside this angle, okay. So we say that the shaded area is the interior, means this area which is given here, this shaded area is what? This is the interior of the angle, okay. And the area other than the interior is called the exterior of angle PQR, right? Next, measurements of angles. We measure angles in degrees. A complete rotation about a point is divided into 360 equal parts. Each of these parts is called a degree. 1 degree is written as like this, 1 degree. A protector. This is a protector and we also call it as D. An instrument called protector is used to measure an angle. This is the diagram of a protector. It is a semicircular in shape. Semicircular means half of circle is semicircle, okay. The midpoint of its horizontal edge is called its central point, means this point, okay. The angle at the center is divided into 180 equal small divisions, each being 1 degree. The protector has 2 scales, inner and outer. One scale begins with 0 on the right and runs to 180 degree on the left. The other scale begins with 0 on the left and reaches 180 degree on the right. Example, find the measure of angle CAB. Method, place the protector in such a way that its central point lies on A, the vertex of CAB, angle CAB, and its horizontal edge lies on arm PC. See, it is shown here. Now observe the mark on the rim of the protector through which arm AC passes. Taking the scale whose 0 degree mark lies on AB, we find that AC passes through 60 degree mark. The measure of angle CAB is equals to 60 degree, or you can also write it like this, okay. Example 2, you have to find the measure of angle PQR. In similar way, you will find the measure of this angle, okay. Now types of angles. Acute angle. An angle whose measure is less than 90 degree is called an acute angle. In the figure, angle PQR is an acute angle, okay, this one. Number 2, right angle. An angle whose measure is 90 degree is called a right angle. In the figure, MNO is equals to 90 degrees. So this is a right angle. An obtuse angle, an angle which measures more than 90 degree but less than 180 degree is called an obtuse angle. So in this adjoining figure, angle WXY is equals to 120 degree and it is an obtuse angle. Number 4, straight angle. An angle whose measure is 180 degrees is called a straight angle. Look at this figure, angle BOA is equals to 180 degree. It is a straight line and a straight angle is equals to 90 plus 90 equals to 180 degree, okay. Exercise 18.2. Measure the length of the sides of the following plane figures using a scale. Okay, students, you have to use the scale and then you will measure the length of each side and you will write over here, right? Perpendicular lines. When two lines intersect and make a right angle, they are said to be perpendicular to each other. Consider two rays AB and BC. Okay. A, B and BC, these are the two rays. Okay. At B, they are making an angle of 90 degree, right? So we write AB is perpendicular to BC. This is the symbol for perpendicular. Okay. Drawing perpendicular using set squares and protractor. Set squares are two triangles items that we see in our geometry box. The angles of one of the set squares are 90 degree, 30 degree and 60 degree, and the angles of other set squares are 90 degree, 45 degree and 45 degree. Example, draw a line perpendicular to PQ at P using a set square. Okay, we will use your set square to draw a perpendicular line, right? Let's see what is the procedure. Number one, place a set square such that the edge having 90 degree falls along line PQ and the vertex at which the right angle is formed falls on P. 2. Hold the set square firmly and draw a ray PR along the edge of the set square perpendicular to that lying along PQ. 3. Remove the set square. 4. PR is the required perpendicular at P. Example 2. Draw perpendicular to AB at A using a protractor. Okay, same procedure will be applied to this example also. Okay, next, circle. In our daily life, we come across objects that are circular in shape such as bangles, coins, wheels, tires, etc. Look at the figure given alongside this one. In the figure, O is the center of the circle. As you can see, this is the center of the circle. Distance of O from every point on the boundary. Okay, see, this is a circle, this is the center, which is O. Now, distance of O from every point on the boundary of the circle is same. That is, OA is equals to OB is equals to OC. Okay. The distance OA represents, this is the radius of the circle. Okay, OB is also the radius of the circle and OC is also the radius of the circle. So we consider the following fact. A circle is a closed figure, each of whose points is equidistant from a fixed point inside it. And radius, it is a line segment joining the center to any point on the circle. Okay, radius is what? Line segment which is joining the center to any point on the circle. Okay, it could be here or here or here also, anywhere on the circle. Okay, chord. A line segment having both its ends point on a circle is a chord. For example, this is a circle, okay, AB, and this is the center. See, this line segment PQ, okay, its 2 points are on circle endpoints. That is why this is a chord. Diameter, it is also a chord that passes through the center of a circle. Okay, but what is the difference between a diameter and a chord? Diameter always passes through the center of the circle, and since its 2 endpoints are on the circle, that's why it is also called a chord. Okay, and clearly you can see that diameter is equals to 2 into radius. Okay, means diameter is double of a radius. Okay, now to draw a circle of given radius, to draw a circle we use a compass usually found in the geometry box. A compass has 2 legs. One leg has a steel end, while to the other leg a pencil is fixed by means of a screw in such a way that the pencil end and the steel end are at the same level. Okay. Example, you have to draw a circle of radius 5 centimeter. Open the legs of the compass to 5 centimeter using a ruler as shown in this figure. Okay. Now mark a point, say O, on the paper like here, and place the steel end of the compass at the point O and turn the pencil end round so that it travels a circle. Remove the compass, we get a circle of radius 5 centimeter. Okay. Next is tangram. Tangram is said to be an old Chinese puzzle. It is a puzzle that is divided into 5 parts or 7 parts. The basic shape of the tangram puzzle is a square. The pieces of tangram are called tans. 5-piece tangram. A 2-piece tangram is divided into 5 shapes: a square, a parallelogram, and 3 triangles, as shown in figure. Using these cutouts, we can make different figures as given below. See these figures. Similarly, there is a 7-piece diagram which has 5 triangles. Okay, 1, 2, 3, 4, 5 and 1 parallelogram. Using these shapes, we can make different figures as shown. Okay, next is tessellation. Tessellation of a flat surface is the tiling of a plane using one or more geometric shapes called tiles, so that there is no overlap or no gaps. As you can see in this picture, there is no gap, there is no overlap. The patterns framed by periodic tiling are called tessellation. Some tiling patterns are given below. It may be noted that if there is a gap in the tiles, then it is not a tessellation as below. See, you can see here gap, but this is not a tessellation because there is gap. Okay. Exercise 18.3. Draw a line PQ. You will draw a line PQ and then draw a perpendicular to PQ at P like this using a protector. Okay, students. Now you will do practice of the remaining questions.